friends and welcome to Obsidian Soft. We started the classic Nokia snake game in the last tutorial and we'll finish its code today. First of all, remember the screen coordinate system. The top left of our screen is 0, 0. Okay, so x is 0, y is 0. X increases when we move right and decreases when we move left. Y increases when we go down and decreases when we come up. Okay, so just remember that. So in each game loop, that is the clock's timer event of 300 milliseconds, we will call a snake movement procedure. And what will happen in this procedure? For example, remember that at the start of our game, we have given this position to the head, x50, y50. And where is the head? The head is at index 1, snake x list, snake y list. Okay, so just remember that. Let's assume that the user presses the right arrow button. So in our move snake procedure that we will construct later, we will check the direction, and if it is equal to right, we will insert a new head at index is equal to 1 with movement pixels is equal to 16 added to the previous head's x. So basically we will be storing the previous heads x and y and we will be adding 16. Remember our global variable move pixels 16 to this thing, okay? And our y will stay the same, okay? So this will be the state of our xy list, that is at index is equal to 1, snake x list 66, snake y list 50, same as before. And at index is equal to 2, we will have the previous head, okay? Now we are drawing close to the food, but we haven't touched it yet. So how is our snake longer now? It now has 2 segments. It has grown longer without eating food. So what we're going to do is, in each game loop, we will also check whether we have touched the food, okay? That will be the collision code, which we will do later, but let's focus on the movement code right now. We will check if we have touched the food, and if we haven't, we will just get rid of this extra tail, okay? And this will give that effect of movement, okay? So every time we move right, we will be inserting a head at a right position by adding a positive number to x to increase it, and we will get rid of the extra tail if the food has not been eaten. As you can see that we have moved right, we were previously here, we have moved right. So this is how the basic movement works. Now let's see when it touches the food. So after 300 milliseconds, we again come inside our game loop and we give a new position to the head. And now as you can see that our collision code will become active and it is now touching the food. So now there is no need to delete the tail, okay? So let's proceed to our actual code. So we are going to make a procedure. Move snake. Remember, we need the xy position of the previous head. So we need 2 local variables. So I'm just going to plug that in and I'm going to make it a little bigger. Okay, so I need 2 variables, so I can drag one here and I'm going to name it previous head x and this is previous head y. Okay, and what are the values? We go to lists and get the select list item log, and the list is snake x list, and the index, remember that the head is at index 1. And if I right click on it, duplicate, plug that in, change this to y list, we will get the previous head y position. Now we just need to insert a new head, that is a new item in both our lists depending upon where we are moving. So if we are moving right, we will be adding the movement pixels to previous head x and y will stay the same. So go to control and get this if then else if block, and we need another else if here. Okay, and I'm going to check using the logic equal to and variables get block, and here I'm going to check if my direction is equal to right. Be careful with the spelling. So if it is right, we are going to insert a new item using lists. Insert a new item, snake X list. We have to tell it that we need to insert it at index 1, because if we use add items to list block, then it will add items to the end of the list. We don't want that. We want to insert it at the heads position. So we are going to use this block that insert the list item at index is equal to 1. And what is the item? It is a plus block. And we will be using the previous heads X. And I can right click, duplicate, and choose move pixels. Okay, so we've added a positive number to head to make it move towards the right, and our Y will stay the same. So I can right click, duplicate, choose Y list, but here I'm just going to plug in the previous heads Y. So does that make sense? We're moving right, we're adding a positive number to X, and our Y is staying the same. And if this is left, so in this case, we will do exactly the same, but now we will be subtracting the movement pixels from previous head X, okay, because our X is supposed to decrease, okay. So if I right click, duplicate, bring it down, and change it to a minus block, okay, and here Y exactly the same. And again, right click, duplicate. Now let's do this for our down position where we add a positive number to Y. So remember that. So X, previous head X, no change in now X for down and up positions, but a positive number will be added to Y. So here, duplicate, and in this case, a plus block, previous head Y. Okay, the last case we don't really need to check. We can just assume that now the direction must be up. And in this case, duplicate, get rid of the plus block and change it with the minus block. Now we will check if we need to remove the tail. I will work on the collision detection code later. So let's just put an if-else block from control. Okay, so just outside the orange block. In the if condition, I will be checking if the collision is true and then I will be increasing the score. But in the else, I will be getting rid of the extra tail. And remember that we have to remove it from both X list and Y list. So if I go to list, I can remove and I can duplicate. Now the index will not be 1, it will be the length of the list, because remember that the last item, the index must be equal to the number of items in the list. So I can go to lists and get the length of list block and right click, duplicate in this, and again for Y. Now we are going to check for screen edges and give a new position to the head if it has reached an edge. For example, here, if I go to designer, if the X of the head is greater than the width of the canvas, then this means that it has reached the right edge, okay? Or if the Y of the snake's head is greater than the canvas's height, this means that it has reached this bottom edge. So in that case, we will give it the Y or the X a new position here. So Y will become 0, or in this case, X will become 0. Okay. So going back to the code, again, we need this 4 conditions block. It has 3 conditions, so we need to add another condition. In fact, we need all else if conditions. So we get rid of this and we plug all conditions in which we are actually checking for the actual condition. Okay, I'm going to use the math block and make it greater than. So I can actually duplicate, because this is the head. And remember that this will be now the new head's position, because we have inserted a new head before. So if my head, the new head, it has an x position greater than canvas's width, I am going to replace. Now we are not going to be inserting a new item, we will be just updating the x item. I'm going to go to lists and get this replace list item block. And what's the list? List is our snake x list. And what's the index? The index is 1, because we will be updating the head, and the replacement will be now 0, because we have to give it, if it is on the extreme right, we have to make it come on the extreme left, so x will become 0. Okay, now similarly, right click, duplicate, and here we are going to check if it is less than 0, because we have to check for the leftmost edge too. So if it is 0, right click, duplicate. Now I'm going to make it, replace it with canvas.width. So come on the extreme right side. Similarly, we will do the same thing for y. Right click, duplicate, and this time I'm going to check y list and the canvas's height. And if it is greater than canvas's height, then make sure that you are updating the correct list. So y list 0. Okay, right click, duplicate. If it is less than 0, right click, duplicate, make it canvas height. Okay, now we have to write some code to detect collisions between circles. Why? Because we have the snake's head, that is a circle, and it should detect when it touches the foot circle. Similarly, we need to know when the snake's head touches any other circular part of its body. We will use the concept of Euclidean distance. Euclidean distance is the shortest distance between 2 points. So if this is the circle, and this is the center of the circle, and this is the center of the second circle, the distance between them can be measured by this formula. If we find this distance between the centers of 2 circles, and this distance comes out to be less than or equal to the sum of the radii, the 2 radiuses of the 2 circles, then this means that the 2 circles are either touching or overlapping. So we have to make a procedure for detecting collisions. So go to procedures, get the second one, the one that returns the result. Let's call it detect collision. It takes in 5 inputs. 1, 2, 3, 4, 5. Okay. So circle 1, x, circle 2, x, circle 1, y, circle 2, y, and this is radius. We will be comparing distance with this radius. Okay, so we need a math block, a less than block, and here we need a multiplication block. And if I hover over radius and this multiply by 2. So if the radius is equal to the size of the circle, the one that we use to draw the circles, then this will be checking for touching. Okay, if we provide a smaller radius and not the circle size, then it will make the detect collision less sensitive. Okay, so more about this later, why I'm changing the sensitivity of the collision detection. Let's focus on the distance formula. So that is square root And we do not have a square block in MIT App Inventor, so I'm just going to multiply the two terms, that is x2 minus x1 together. Okay, so if I go to math, get the plus block, okay, and here I have to multiply, and the two terms are actually minus blocks. And if I hover over x2, and if I hover over x1, and if I right click, duplicate, so this will give me a square. And similarly, I need a square for the y2 minus y1. So change this to y variables accordingly. Okay. So this will return a true or a false, okay? The result will be a Boolean value. Once we have the detection code, let's complete this if condition that we left. And we are going to call our procedure detect collision, okay? And now it requires all these values. So what is x1? x1 is the x of our head's position, okay? Right click and duplicate, and this will give me the x of the head's position, okay, and x2 is our food's position, okay. So if I go to variables and I get the get block and I choose food x here, right click, duplicate, choose y, right click, duplicate, and choose food y, okay. And the radius in this case, because we want it to detect even touching, I'm going to use the radius of circle size, okay. And if it is true, what should we do? We should increase our score by 1. So get the set block, score, go to math, get the plus block, variables again, get block, score, and add a 1 to it. But we also have to update our score label on the screen to reflect this change. So go to score label and get its set text block, and it's a join. Where the first segment is score colon space, and this will now contain the new score, okay. And last but not the least, since the food has been eaten, we need to give this impression that it has disappeared. And how can we do that? We just give it a new position by calling our procedure place food, okay. So our move snake procedure is finally complete. Now we can finally work on our game loop, and our game loop is basically just the clock's timer event, which is fired after every 300 milliseconds. And first of all, we are going to call our procedure move snake, which will do all of this code, that it will move the snake, it will check for screen edges, it will check for food detection. And after that, we are going to check for collision of the snake's head with any part of its body. So we are going to use a for loop from control, which actually starts from 2, okay, and it goes up till the length of the snake, which we can find using any of the snake's list, X list or Y list. Both will be the same size. And then we are going to use an if-then block for detecting collision by calling the procedure detect collision. And here, what is x1? x1 is the x of head, okay? Okay, so if I duplicate, bring it down and make this snake X list. And this should be the X of whatever part of the body we are comparing with. So if the number is 2, then it is the X position of the second segment inside the snake's body. Okay, so if I right click, duplicate and change this to number by hovering over it. Okay. So we will compare the head with each other part of its body because we are starting from number 2. So if I right click, duplicate, make it now Y list, right click, duplicate, and make it now Y list 2. And this radius I am going to provide the value 4 and not the circle size of 8 because I want the collision detection between the snake and other parts of his body to be less sensitive. Why? Because the snake's head is always touching the second segment of its body. So I don't want it to be so sensitive that our game never progresses beyond the first iteration. I want the snake to become longer, and when it actually goes over it, that is, the head overlaps some other part of its body, then the game over is triggered. So this is why I've made the radius 4. And if this is true, in that case, what I want to do is that I want to first of all disable my clock so that the timer doesn't run anymore. Okay. And logic false. And then I am going to set my, remember the game over variable? I am going to set it to true. So I can right click, duplicate, and make it true. And then I am going to use the controls break block. What it will do is that as soon as it detects a collision, for example, it detects a collision between the third segment of the body with the head, then we don't need to do any more checking. We just need to trigger game over. So just break out of this loop. Okay. And in the end, we draw everything by calling this procedure draw. Okay. So this is a final game loop and the snake game is finally complete. Thank you for being patient and waiting for the part 2 of the tutorial. I hope you enjoy making the game as much as I enjoyed designing and creating it for you. Please don't forget to subscribe if you haven't done it yet so that you don't miss any of the great tutorials that I've planned for you. Thank you for watching. Have a great day and goodbye.